All right, Chapter 3, Sections 1 and 2 review. You guys have a test after I'm done with this review. In addition to that, you are going to have time to finish the test tomorrow in class. Now, let's go straight to this problem. We have 7x minus 6y is equal to 12 and 4x plus 3y is equal to negative 6. If you chose to do problem 18 on last night's worksheet, which was Chapter 3-2, LC and substitution worksheet, I told you guys the directions were on Edmodo that you had 4 to do by elimination and 4 to do by substitution. I am going to quickly go over a few of those methods so that you guys can do well on the test today. So the first thing I'm going to look at this and I'm going to say, is there a shortcut to this? In other words, am I looking for any no solutions, meaning parallel lines, or am I looking for same equations? And since 7 and 4, there's nothing I can do to get that and change those, and the 6 and the 3 and the 12 and the negative 6, this is going to be one that I'm going to have to do elimination on. So I'm going to go ahead and I'm going to find the least common multiple of my x's, and that's going to be plus or minus 28. The least common multiple of my y's is going to be plus or minus 6. 28 is too big of a number, so I'm going to focus on the 6. So that means I already have equation 1 already has a negative 6 to it, so I leave this alone, and I'm going to multiply the bottom equation by what to get a positive 6y? And that's going to give me a 2. So I drop down the top equation because it is going to be unchanged and left alone, and I distribute the 2 to the bottom equation. 2 times 4 is 8x, 2 times 3 is going to be 6y, and 2 times negative 6 is negative 12. At this point, what I need to do is I need to add the 2 equations together. So when I add them together, this gives me a 15x, my 6y's cancel out, and it just so happens that my constant terms cancel out as well. So now I'm down to one equation with one unknown, and I'm going to solve this. So how do I solve this? I divide both sides by 15 to give you x is equal to 0. So if x is equal to 0, now what do? I go back to my original problem, doesn't matter which one. I'm going to choose the bottom equation because the numbers are a little bit smaller. And I'm going to plug in what I know x to be. X is 0, so 4 times 0. So that goes away. 3y is equal to negative 6. Divide both sides by 3, and you're going to get y is equal to negative 2. My point of intersection is going to be the set containing 0, negative 2. This was an independent system. Why is it independent? It's independent because I can physically see the point of intersection there. This, ladies and gentlemen, is elimination or combination, whichever one you want to view it as. Okay? Again, number 9. Number 9 is off the same exact worksheet. I give you 5x minus 3y is equal to 10, and 5x minus 3y is equal to 13. So before I move on, I want to be logical about this problem. I need to say, okay, well, is anything the same about them? Well, both sides on the left-hand side are exactly the same. 5x and 5x, negative 3y and negative 3y. Those terms are the same. What is not the same is going to be what it equals. 10 and 13 are not equivalent. So what you need to see is that these are actually going to be parallel lines. Okay? And parallel lines do not cross ever, so therefore their point of intersection is going to be no solution. How do I prove this? Just multiply this bottom one by negative 1, drop down the top, distribute the bottom, and what you're going to get when you add straight down is 0 is equal to negative 3. This gives you a false statement. Since it is a false statement, this means that there is no point of intersection and that they are parallel lines, meaning they are an inconsistent system. Okay? Next, number 12. Number 12, the same worksheet. If we look at these and let's be logical about it, 4x and 11x, negative 5y and 2y, 1 and negative 13. Nothing right there is going to be the same. Nothing appears to be equivalent, so I know they're not going to be equal, and I also know that they are not going to be the same line. They're not going to be the same line for infinitely many solutions, and they are not going to be no solution, meaning inconsistent, because they are not equal to different numbers. And the same on the left-hand side, just like this example was. Okay? So I'm going to go ahead and say, can I do elimination on this? I could, which would make it easiest. Or could I do substitution with this? Substitution would be very difficult with this problem because none of my coefficients are 1. So what that means is I'm going to go ahead and I'm going to do my LCMs again. My LCM of my x's is going to be plus or minus 44. The LCM of my y's is going to be plus or minus 10. So with that said, I have the top equation. It's already a negative 5y. I'm going to focus on eliminating my y's because 44 is just ridiculously large and no one wants to work on that. This is a negative 5y. The bottom one has a positive 2y. Since this is already negative, what am I going to multiply negative 5y and turn it into a negative 10y? Well, that's going to be multiplying by 2. So this gives me an 8x minus 10y is equal to a 2. Now, what do I multiply the bottom equation by to give myself a positive 10y? Well, that is going to be multiplying that by a 5. And if we do that, I'm going to have 55x plus 10y is equal to negative 65. Okay? Then from there, I'm going to add straight down. If I add straight down, 55 plus 8 is going to give you a 63x. Those cancel out, and this is going to be equal to a negative 63. Divide by 63, x is equal to negative 1. Now, with that said, I need to go ahead and I need to find y. How do I find y? I go to one of the original equations. It doesn't matter which one. I'm going to choose the top one. The numbers are nicer. And I'm going to plug in what I know. 4 times negative 1 minus 5y is equal to 1. Negative 4 minus 5y is equal to 1. Add the 4. Negative 5y is equal to 5. Divide by negative 5, and you're going to get y is equal to negative 1. So again, my POI, x is negative 1, y is negative 1, and this is going to give you an independent system. Okay? Now, this is number 16. If I look at number 16, I'm going to go ahead and use logic again, and I'm going to say, well, if we look at this, how do I go from 4x to 12x? Well, I multiply by 3. How do I go from negative 1y to negative 3y? I multiplied by 3. How do I go from negative 2 to negative 6? I multiplied by 3. Since I multiplied by 3 and I got since I multiplied the entire bottom equation by 3 to get the top equation, these are essentially going to be the same line. Now, let's say you had no idea that that was what was going to happen. How do you go about finding the equation of this? Well, I'm going to use substitution, and I'm going to take equation 2, and I'm going to solve it for y. So that's going to be 4x minus y is equal to negative 2. So if I go ahead and subtract 4x from both sides, I get negative y is equal to negative 4x minus 2, and divide each term by negative 1. Y is equal to positive 4x plus 2. I'm doing this by substitution because I haven't shown you substitution. I think everybody needs to remember how to do that. I would probably have done elimination on this problem if I had the opportunity. Now that I have solved this for y, I'm going to go ahead and take the equation I have not used, which is equation 1, and I'm going to plug and chug. So I have 12x minus 3y is equal to negative 6. And every place I see a y, I'm going to plug in the expression 4x plus 2. So I have 12x minus 3 times 4x plus 2 is equal to negative 6. Distributing, 12x minus 6 is equal to negative 6. The 12x cancels out, and I have negative 6 is equal to negative 6. Since that is a true statement, there's nothing I can calculate. This tells me that it is indeed the same line, and this becomes a dependent system. And that means my point of intersection is going to be all the ordered pairs x comma y such that they fall on the equation 4x minus y is equal to negative 2. You must write it in that form. If you don't, you will get it wrong. So I've talked about independent, dependent, and inconsistent. Those are all the different things that we talked about. Yesterday we talked about graphing. You are going to have a story problem on the test. So if you have a story problem on the test, you're going to have to go ahead and read it and figure out the equation. Now, Lynn went to a fast food restaurant and spent $20. She purchased 4 hamburgers and 5 orders of French fries. The next day, Johnny went to the same restaurant and purchased 10 hamburgers and 7 orders of fries. He spent $41.20. Determine the cost of a burger and the cost of an order of fries. Well, my variables are going to be, H is going to be for hamburgers. And then I'm going to have F is equal to my French fries. So we're going to first look at Lynn and how much she spent. Well, she spent $20, and what did she purchase? 4 hamburgers, so that's 4H, plus 5 orders of fries, so 5F, and that had to equal a total of $20. Then Johnny came the next day, and how many hamburgers did he purchase? 10 hamburgers, and then 7 fries, and he spent a total of $41.20. And from there, you guys can go ahead and finish the problem yourself, but I just want to make sure that you understood how to get the equations. So one more time, and I know we went over some of these in class the other day, but I want to make sure that you're ready for the test. In 1994 Super Bowl, the Dallas Cowboys scored 4 more points than twice the number of points scored by the Buffalo Bills. So what are my variables? C for Cowboys, and B for Buffalo Bills. Now, it says if the total number of points scored by both teams was 43, what am I going to do to get the total number of points scored? I'm going to add the Buffaloes and the Cowboys together to get total points of 43. So I'm going to have Cowboy score plus my Buffalo Bills score has to equal 43 total points. Okay? That comes from this sentence right here. However, I ignored the very first sentence, so we need to go back and we need to look at that sentence. It says the Cowboys scored 4 more points. 4 more means what operation? Well, that's going to indicate plus 4. Then twice the number of points the Buffalo Bills scored. Well, do we know how many points the Bills scored? Nope, so that's going to be B. Twice that's going to be 2B. So that means my Cowboys are equal to twice the Buffalo Bills plus 4 more points. Now, I would have used substitution to solve this to be able to find out what your Bills were first, and then you would have found what your Cowboys were afterwards. Okay? Now, we've talked about everything. Here are the answers to the worksheet. If you would like to check those, Mrs. Freitag can pause this video, and she can go ahead and let you guys have opportunity to check your answers. In addition to that, these are the steps that you would need to do to solve for elimination. These are the steps to solve for graphing. You will have 3 problems on the test over the graphical method, which is what I talked about yesterday. Solve each equation for y, put them into your graphing calculator, hitting tab to go to the next function, and then from there you are going to do menu, analyze graph, and do the intersection point. I will have Mrs. Freitag put these up on the board for you so that you guys are able to have these up the entire time you're taking the test. Good luck. Start the test today. Collect them by putting them in the top bin on my desk. And then tomorrow we will redistribute those tests for you to be able to finish up before break. Have a great day.